Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give you a practical example of a two-way Anova. And here we have a problem where a researcher here wishes to see whether the type of gasoline used and the type of automobile driven have any effect on gasoline consumption. So this one here is the first factor, and this is the second factor. So gasoline consumption is the dependent variable. The levels of gasoline are regular and high octane. So these are the levels of factor 1. And then for the second factor, which is automobiles, there are two types, two-wheel and four-wheel. So this is also the levels related to factor 2. And it says here that there will be two automobiles in each group, and since each factor here has two levels, there will be 4 different groups, and if two automobiles are used in each group, therefore the total of sample size is going to be 8. Okay, let me just write it down for you clearly. So here we have types of gasoline, which is the first factor, and here the consideration is regular and high octane. And then we have another factor, which is types of automobiles. This one is two-wheel and this one is four-wheel. So therefore in this case the factorial arrangement is going to be in this manner. You can have regular gasoline with two-wheel type of automobile, or you can have a regular gasoline with four-wheel automobile. You can have high octane combined with two-wheel, or you can have high octane combined with four-wheel. So clearly there are 4 different treatments which require 4 different groups, and here we have 2 automobiles used in each group, so therefore total sample size is going to be 8. Alright, so the question is asking you to state the hypothesis of interest, and therefore we have 3 different H null. And next you will have to complete the Anova summary table given in the next page. And finally, using the significance level 5%, you have to conclude the results of your analysis. Okay, so we are going to start off with stating the hypothesis of interest. It's going to be a long statement. So instead of writing it down, I have typed it so that it looks nicer and it can fit the whole space given here. So here is the first null hypothesis. Okay, so this is H null 1, and this is the alternative to that null hypothesis. So look here that there is no difference in the means of gasoline consumption is your dependent variable. So no difference in the means of dependent variable when using this first factor here, types of gasoline. So for the alternative hypothesis, it is just a contradictory statement. Therefore, there is a difference in the means of gasoline consumption. So this is the dependent variable when using different types of gasoline. So here is the first factor. We are talking about the first factor. Right, so let's talk about this to be specific. So here is the first factor, which is related to gasoline, types of gasoline. Next, the second null hypothesis, the second set of null and alternative hypothesis? Well, as you can see here, oops. So here we have H null 2 and H null 1. And if you can see, the statement here is, I'm sorry. Okay, so here there is no difference. For the null hypothesis, is no difference in the means of gasoline consumption, which is the dependent variable, when using different types of automobiles. So here we are talking about the second factor, which is the types of automobiles. This one is the first factor. Well, as the alternative hypothesis, it is very easy. We can see that there is a difference in the means of gasoline consumption when using different types of automobiles. Excuse me. So this is the second factor. And finally, what we have is the last set of hypothesis statements. So here we have H null 3 versus the alternative of the third hypothesis here. So here we are focusing on the interaction, okay? So for the null hypothesis, no interaction effect between, this is factor 1 and this is factor 2. So no interaction effect between factor 1 and factor 2 on the dependent variable. And again, for the alternative hypothesis, we're just going to have a contradictory statement which says that there is an interaction effect between factor 1 and factor 2 on the dependent variable. So it is as simple as that. So this is related to combination of factor 1 and factor 2. Okay. Right, so now we are going to complete this table. And here, the degrees of freedom for gasoline. So here is factor 1. This one is factor 2. And this is for interaction, clearly. And this is the within error. So the degrees of freedom for gasoline will be the number of factors in gasoline minus 1. So gasoline here has 2 factors, regular and high octane. So 2 minus 1 is going to be equal to 1, the degrees of freedom. Similarly for automobile, the number of levels is 2. So 2 minus 1 is 1. Okay, now interaction is simply multiplying the degrees of freedom on this one and this one. So the result is going to be equal to 1. And for this one here, the formula to find the degrees of freedom is AB n minus 1. So here n is the number of sample size in each group. So which is equal to 2. A here is the levels in factor 1, which is the levels in factor gasoline, which is 2. B is the levels in factor automobile, which is also 2. So 2 times 2, and here minus 1 is going to be 1. So 2 times 2 is going to be 4. So here is the degrees of freedom is 4. 2 times 2 times 2 minus 1. 2 minus 1 here, okay? Right. Now, total values for these two parts here is 70.98, and for this one here is 7 degrees of freedom. Alright, then we're going to find the values of mean square. So to find the mean square at this position, what you need to do is you need to have this divided with the degrees of freedom. So the answer is going to be 3.920. In a similar manner, this one divided with the degrees of freedom is 9.680. And this one divided with the degrees of freedom is 54.080. And 3.3 divided with 4, the answer is 0.825. Now here is going to be the position of denominator that will be used in calculating the F statistic. So for the first position here, for this one, the F statistic is going to be this one divided with the denominator. So 3.92 divided with 0.825 is 4.752. And for this position here, we will have 9.68 divided with 0.825. It will be 11.733. And for this position here, we will have the value of 65.552. Okay, this is quite easy. So now what we're going to do is we're going to consider the critical values. And because we have 3 different tests, now we are going to consider 3 different critical values for each of the tests. But since the degrees of freedom here is equal, you will end up getting the same critical values anyway. So never mind, I'm just going, for the sake of clarity, I'm just going to draw 3 different curves. Okay, so this is designated for the first null hypothesis, which is about gasoline. And this is designated for testing the second null hypothesis, which is about automobile. And this is for the third one, which is the interaction. Okay. Now, the significance level is 5%. So 5% is for each of the tests. So here is the 0.005. And over here is also 0.05. And on this side is also 0.05. So your job is to find what's the value over here on the horizontal axis here, such that the area from this point to the right direction is 0.05. Yeah, so this is the critical values that you need to find. And in this case, the degrees of freedom for the first null hypothesis is 1 and 4. Similarly, for the second null hypothesis is also 1 and 4. And for the third one here is also, for interaction also is 1 and 4. So because of that, we will be getting the same value for the point of interest here. Now, if you refer to the F distribution table, where the area is 0.05, degrees of freedom for numerator 1 and denominator 4, you will see that the critical value that you are looking for is going to be, at this point, is 7.709. So we have the same value because fortunately we have the same number for degrees of freedom. So that's why we got the same value. Okay, so now for the first null hypothesis, this value here will fall somewhere here. So 4.752 will be somewhere here. So it doesn't fall into the critical region. For this one, it's going to be somewhere here, 11.733. And for this one, it's going to be very far away. So it's going to be very far compared to, the position of it is going to be very far compared to this value 7.7, because this is 65.552. So therefore, based on this, our decision is we can reject the null hypothesis related to this one and this one. Right, so the decision is able to reject H null 2 and H null 3, since the test statistics 11.733 and 65.552 respectively fall into the critical region. So that's the decision, right? And as a conclusion, since this null hypothesis H null 3 is related to interaction, so if you are able to reject the null hypothesis here, which means we are saying that interaction exists, there is enough evidence to say that interaction exists, and because of that our focus is now more on the interaction rather than the mean effects. Okay, so as a conclusion, since there is enough evidence to say that the interaction, to say that there is interaction effect, or to say that there is a significant interaction between types of gasoline and types of automobiles on the gasoline consumption, therefore, or let me see, since what we can see is no need to have the word since, so we can say that there is enough evidence to say that there is a significant interaction between types of gasoline and types of automobiles on gasoline consumption, and because of that the focus is now on the interaction effect rather than the mean effects. Or if you want, you can also say that there is enough evidence to say that there is a significant difference on the means of gasoline consumption when using different types of automobiles. You can start off with that conclusion, but then because we are able to reject H null 3, therefore we might be interested to look at the interaction effect rather than the mean effect. So this is something that is related to my statement over here. Okay, so here if let's say the interaction effect is significant, therefore the focus is now shifted to the interaction effect rather than the mean effects, or rather than the effect of factor 1 or factor 2 independently. Okay, right. Okay, so I guess that's all for now. Thank you very much for watching.